Welcome to Technovation. I'm your host, Peter High. My guest today is Gadi Singer. Gadi is a vice president of Intel Labs and the director of Emergent Artificial Intelligence Research Lab at Intel, a company he joined 4 decades ago. In his current role, he and his team drive innovation in machine learning and cognition, combining deep learning with deep knowledge structures and symbolic reasoning to materially improve efficiency, explainability, extensibility, and reasoning capabilities of artificial intelligence systems. I look forward to speaking with him about all of the above and more. Gadi, welcome to Technovation. It's great to speak with you today.
Great being here. Thank you.
Well, maybe we can begin, Gadi, with the context as to your Emergent Artificial Intelligence Research Lab. Talk a bit about the mission and the area of focus of the lab itself, please.
So within Intel Labs, I lead the research activities that have to do both with bolstering and supporting the continuation of the current wave of AI, as well as looking at some technology trends that might be transformative, that might be of significant change value in this decade. So we're looking at aspects like how to optimize existing deep learning models in a very significant manner, how to allow it for use for the longer tail of users and users. But at the same time, we're looking at things that are up and coming. Aspects that are driven in my lab are neuromorphic AI, as an example. We're looking at aspects of meta realities that are coming up as a significant trend. And we're also looking at cognitive AI, which are the set of technologies that allow AI to become that much more capable in cognitive abilities, which we can definitely dive more into.
I very much look forward to doing so. Before we get there, though, I'd also like to understand, talk a bit about the team around you as well. This is such a complex topic that tends to be multidisciplinary in nature. May I assume that the team that you surround yourself with reflects that necessity to have people from a variety of different disciplines, Gadi?
Absolutely. And especially when you talk about cognitive AI, there are several disciplines that need to come together. The model for cognitive intelligence is human. So we have cognitive scientists as part of the team. We look at neuroscience as a major source of inspiration, as well as actual learning of how it happens. So we have neuroscientists that are looking at fMRI and what can be learned in terms of the flow of activity in the brain in various types of reasoning as a guide for some of the activities that we're doing. We have linguistics in our team, because a lot of the discussion about the form as well as the meaning that comes in language is better understood by people whose profession is linguistics. And of course, we have AI or data scientists, and we also have computer scientists. So we have a combination of all those disciplines to create a more well-rounded view. And in general, I found in the past that many of the breakthroughs come from cutting across disciplines. In many cases, you have a lot of emphasis within one discipline, but when you're opening it across disciplines, you have different ideas, different synthesis that can really bring forth a new direction.
Gadi, artificial intelligence is not a new topic. It's been contemplated for quite some time, but it's really sort of the past decade that it shook loose of what was commonly referred to as the AI winter, a period where it had gone somewhat dormant as progress had stagnated for some time. I know from our past conversations, you referenced a series of waves of AI that have emerged across the past decade that have been meaningful. As additional context setting, can you talk a bit about those waves and the relevance of each of those as we look forward as well?
Of course, and we can talk about a history because other people might have slightly different views, but it's generally perceived to be partitioned into 2 waves. The first wave was what may be called a symbolic AI. And in that wave, the main approach was that people can program the AI, can teach it in terms of the knowledge structures, in terms of the programs, can teach it how to perform very intelligent tasks. And the knowledge basis was symbolic. So you had items like a dog and a house and things like that. And there was a lot of knowledge that was inserted. And if it was in a particular area like banking, you had experts that put in their rule-based systems. And that was the first wave. And it kind of fell short of expectations, even by the people who created that wave. So the whole field went into a couple of winters with a little bit of awakening in between. And then starting in the 2000s, there was the second wave of AI, which is based on an approach that's called connectionist or neural networks. And that approach said that if you create structures, waves and waves, or layers and layers of neuron-like constructs, and it's implemented by regular compute, but it emulates kind of how neurons work in the brain, you can actually teach the machine to learn. So rather than teaching it what to do, you teach it how to learn. So this is the whole wave of machine learning. And this neural network, or what's called deep learning, because it has deep layering, it showed just tremendous progress, especially over the last decade, where things that are associated, for example, with perception, like vision or analyzing language, can be learned by the deep learning, machine learning, by giving it lots of examples. So you don't have to describe to it what a face looks like, how a dog is different than a cat, but rather you give it enough examples that it builds a model in the machine that learns those features and learns to operate on those features. And this statistical-based method has been tremendously successful. It's the second wave of AI. And I see it as having so much more potential in the coming decade and beyond. So it is by no means reaching another winter or a slowdown. I can see it now being proliferated. Many businesses, so people who are listening to this in whatever space they are, if you have a pattern that you need to distinguish, if you have recognition, if you need to do a translation, deep learning can have a tremendous value to many, many segments. However, this second wave, even though it's going to continue and proliferate, has some limitations, some fundamental limitations, which we can talk about. And therefore, there's an expectation that this decade will see the emergence of a third wave. And that third wave might be just an improvement on deep learning, or, as I believe, and several other researchers, leaders in the field, it might be actually created by the combination, by the synthesis of the first two waves. So if we had a symbolic wave and a neural network wave, that third wave that's emerging now, and you'll see it more and more during this decade, might be the neurosymbolic third wave of AI.
Well, let's get in, as you referenced a moment ago, Gadi, into some of the limitations, at least to date, and the extent to which you see the neurosymbolic wave helping out or allowing for progress past some of those. I realize not all of them will be reconciled or rectified in the immediate term, but talk a bit about where the limitations have been, at least of late.
Well, there are several limitations. Probably a major one is the size of the models, the complexity of the models. As the models continue to grow, they've grown probably 10x every year for the last decade. That is not a sustainable trend. You cannot grow anything by 10x sustainably. And part of that is because the models, rather than trying to conceptualize, generalize, use additional data sources, in many cases, they're aggregating, they're memorizing and aggregating a lot of information so that they can reference it. And there are some techniques which are working in another part of my lab on how to distill, how to create a more minimal model that can be used for particular cases. But still, we need a different approach where we do not have a neural network model that continuously grows every year by 10x. Another aspect is the aspect of the human-machine interaction. There are things that are required, first and foremost, explainability. When a machine learns to do something, when it gives you a recommendation, it needs to be able to explain its findings. And in some areas, like if you look at supporting medical analysis of medical imaging, there's a huge difference in the ability to accept the outcome if the AI can tell you why it recommends, why it thinks it identifies one, or if it's in a loaning system or any of those others. Another area which needs addressing is the robustness of the solutions. In many cases, when you're using statistical systems and they learn the features, they learn it by identifying some markers, by identifying some aspects of what they see. But they don't always generalize. They don't look at the principle, the concept behind it. We as humans use concepts a lot. So you know about traffic signs, and you know that there are traffic signs that are like a triangle. There's one that might be in a hexagon or a round, and you understand a lot of things within those concepts. A statistical system, in many cases, is much more susceptible, and therefore we need to work on the trustworthiness and the robustness of those. And finally, there's the whole set of cognitive abilities that the third wave need to address. In a way, the second wave is great in dealing with things we do in their mind, in the back of our mind, things that have to do with perception, with intuition, with things that can be addressed immediately. Where AI is growing is to things that are more related to the front of our brain, to the prefrontal cortex, to the aspects of planning, of reasoning. And Yoshua Bengio, one of the kind of luminaries in the field, described it very well in a keynote he delivered in NeurIPS conference in 2019. And he used Daniel Kahneman's model of thinking fast and slow. And he talked about having two systems of thinking, which need to be kind of a model for what we do with AI. The first, system one, is the one that is habitual, intuitive. And there are things that you do without thinking. You do it instantaneously. And the example that was given is if you're driving in those times we used to drive to work, hopefully coming back soon, and you're doing a familiar route, and you can, while you're driving, you can be on a call or you can talk to somebody, and you're doing this more or less automatically, even though it's a pretty complex task. That's a system one. System two is one that requires much more cognitive abilities of thinking, reasoning, planning, maybe doing a quick simulation or theorizing of what happens if I do this or I do this, and then choosing the best option. And this is system two. So in the same driving scenario is you're driving through an unfamiliar area. There's some construction, there's some obstacles. You're not going to, hopefully, do other things. You're going to pay full attention to what it is. You're trying to think about what that might mean, water in the road, what it is. And this is where you're really applying system two, where things are not ready for instantaneous answer. You need to apply reasoning, you need to apply common sense. And this is where the third wave is going. And the third wave, by many, is believed to be just an extension of deep learning, or just neural network done better. And particularly, I mentioned Bengio and others believe that you can implement this third wave, this system two type, in a way that's just a better deep learning. I believe that you need to use all the strength of deep learning, but there's tremendous value to also use the type of representations and reasoning on symbolic value from the wave one. So wave three would either be an extension of deep learning or, as I believe, a combination of the two as neurosymbolic wave.
Very, very interesting, Gadi. I appreciate that overview. You know, AI one of the remarkable aspects of it is so much progress has been made, and yet it is forever a future topic in some ways. I think there's a tendency for many people to take for granted the advances that have been made, and perhaps some of it is the promise, and in some cases the worry, of artificial general intelligence, which many pontificators, who please let me know where you feel differently, believe is decades out, perhaps at a minimum, where the artificial intelligence can truly replicate the wonders of the human mind to a much greater extent, overcoming many of the things that you have described. And I wonder, it's interesting as you have seen things advance. In fact, as you have played a role in that very advancement. I have to imagine that it's given you a new appreciation for the wonders of the human mind. And as you've sort of contemplated the complementarity, especially at least for the time being, between artificial intelligence and our own intelligence, are there ways in which it's given you sort of a new appreciation for our own biology, for the way in which our own minds work?
Absolutely. It's an amazing machine, and it's much more than that. And definitely looking at how difficult it is to deliver even relatively lower capabilities than that gives increased appreciation of what humans can do. And we are not, I believe that AGI is far away. We're looking at what can be done in the coming decade that's significantly more than the statistical approaches that were done before. And even those statistical approaches, deep learning is already delivering on the promise of AI significantly, but more can be done. So what is this intermediate level, which is the next wave? And what will we be able to see AI doing? So first, which seems simple, is multimodality. We take in visual information, we hear things, so language and other auditory information, and we look at actual data. And any type of intelligence that goes beyond what we have today must be multimodal. It needs to be able to really tie together the different modalities. So when you hear about something, or you see it, or you read the data, it needs to all come to the same place where you can extract and reason on later. It needs to include true comprehension. Today, a lot of the statistical reasoning brings you to what is the most likely outcome based on statistics, based on all the data. Our comprehension is much more than that. When we hear the word grandma, okay, there's such a rich structure that we have in terms of particular grandmas in stories, younger people, older people, things that we know about medical condition and so on. So think about this question. If I ask an AI, how's grandma doing? Today's AI cannot really deal with that. It cannot really comprehend the question. There's so much context that's required in order to understand it. You need to understand which person I'm talking about. So who is my grandma? And what do I already know? So what will be new for me? What is usually the state of well-being for somebody her age, and what might be different that might be relevant? And so on. There's so much context. And so we need to move from a more generic AI to one that comprehends language, comprehends situation, and is highly contextual. And one that is better customized. So we need to make sure that when my car or my house, or if you're a dentist in your practice, your AI can reference fully to your context rather than needing to just rely on some general huge information source. Explainability we talked about. If the AI tells me, how's grandma doing? It better follow up in some conversation. AIs today, for example, cannot process a 5-minute video in an effective enough manner so that they can converse and explain their observations and so on. And that's something that's coming this decade. And also collaboration and enhancing or aid to people. We see AI as an extension, as an aid to people. And so the ability for AI to really expand on the things that we needed to expand, like access to information or things that it can help us with, and allow us to be ourselves in the most essential manner while extending our abilities. All those are things that we can see happening to a much larger extent in the coming decade. And maybe to give you a little bit of a timestamp on that, I believe that this third wave of more cognitive AI is where deep learning was about a decade ago. So if you think 2012, a decade ago, this was the first time that neural networks was used over a test called Emergent benchmark. And going from having 30-some% error rate, which was not usable in identifying images, over just several years, were better than human ability to recognize images, a very simple task, but we're matching this within several years. And so in the beginning of the 2010s, it was very early. By 2015, it was used by some companies, the early adopters, the ones that had enough expertise to take a technology that was not fully kind of baked for use, very broad use. But by the end of the decade, by 2020, deep learning was proliferated to many users, many companies, many usages. So I see this next wave of cognitive AI as having a similar trajectory, similar pace over the 2020s. And we are now in an early nascent state. And by 2025, I expect to see some of those capabilities like multimodality, like reasoning over common sense, being both benchmarked as well as showing significant results. And then by the end of the decade, being proliferated much broader.
Are you at all worried about, as the AI progresses, either bad actors or the AI itself doing things that run contrary to what's best for humanity? How do you feel about that? And what sort of are you the extent to which it is at all a concern? Do you feel as though appropriate safeguards are being put in place?
I think that it is being worked and they are being put in place. It needs to be a continuous dialogue between the technical community and others that contribute to this to create some guidelines. And it is a very important topic. So we should look at technology in the context of how it helps individuals and how it helps humanity. And so everything that we do within cognitive AI is within this context. And I believe that actually it can help in that. And let me give you a couple of examples. The concept that we're having is that a cognitive AI can have its own neural network and also its own data, which it can operate on. By having its own data, it can actually protect privacy better, because by having your own data, all the information about grandma and so on can actually be local. So you can customize without having to move your data, your information, to a central place or to a place which influences others. So having the ability to keep local information is a way to help preserve privacy. Another example where the approach that I'm pursuing helps is that we're proposing to have a symbolic database, a symbolic structure, like a knowledge graph, where you build your knowledge the same way humans build their knowledge. And you build it with a way to annotate it. What was the source of the information? How many times did I hear it? And this has an inherent advantage over a statistical method by itself, because let's say that you have two groups of people promoting something. They have a different view of the world. And the first group has much more access, and it has 80% of the information out there comes from group A. And group B only has 20%. They're not necessarily less correct, or their perspective is less relevant, but only 20% of the information is there. So when you look at it in a symbolic knowledge graph and you annotate it, you know, you don't just use the statistics. This is probably better than this. This is more prevalent. You know that this view with this information came from this source, and this view with this information came from that source, and it came with that distribution over the years and over the different media. So you're much more conscious, or the machine can better analyze versus bias. It is actually a tool. It provides a substrate to addressing some things that when you just rely on statistics might get lost.
That's a great overview. And And a very interesting explanation of that as well. As we talked about earlier, this takes a whole range of disciplines coming together in order to overcome in order to see the progress already made, but also to overcome some of the challenges that are ahead as well. And as you've mentioned to me, you've emphasized the necessity for an open source aspect of this in the pre-competitive space, so to say, where there's a great deal of collaboration from the universities, from the private sector, from a variety of different labs that focus on this, that have very long-term perspectives in terms of their investments and the way in which they direct their activities. But then, of course, and you work for a private company and thinking about the process of then making it competitive and commercializing and so on. Talk a bit about the sort of tension between those and how you think about the open space where there's a lot of collaboration and the eventual walled garden where one company takes advantage versus another based on the progress or the innovations that they establish.
This is very interesting. The dynamics is different from other spaces that I've been in the computing world for many years, and the way AI progresses is through the algorithm level. Algorithm level is the kind of the top level recipe or the flow of how you do things, how you architect your information, how you do things. And what's happening in the AI world is that there's a lot of collaboration across industry and academia between companies on this algorithmic space. And we see it in many cases as a pre-competitive space. So I'm advocating a 3-level knowledge, a 3LK architecture, which we can talk about. And I'm talking about it openly. I'm writing blogs about it. I talk to my colleagues from other companies, and I also listen to them. And we usually publish our papers and our blogs in a way that everybody else can progress. Why? Because driving the state of the art of AI in a way that's done for good, for everybody, for capabilities, for improving the way we use our resources, for being able to understand climate change, all those aspects are things that we need to look at together. So this algorithmic space is usually considered pre-competitive in the sense that we share our knowledge and we progress quicker by learning from others, but also sharing with others. And then there's the space of implementation. And some of that is open source, but some of it probably, if it's hardware or if you have a business model that takes particular direction, you do that as part of your competitive space. And that petition and that level of sharing at the pre-competitive space allows AI to move so much faster than any other technology space that I've seen in the past.
So, Gadi, you referenced the third wave, the neurosymbolic wave, and some of what that will entail, combining the first and second waves as you described. Talk a bit about the way in which that's going to take shape. How will that be done, please?
This is something that's being worked on with on various labs, and I can describe how we're pursuing it. So we look at it as cognitive AI because it provides all those cognitive abilities. And specifically, we're talking about an architecture that has 3 levels of knowledge, 3LK, or for short, 3LK. And we model it based on how we as humans work. So the first level is really information that's right at your habitual or instant answer. If you have a physician and she's being asked, can we administer those 2 medications together? She might have given the same 2 medications several times that morning even. So the answer is immediate, yes or no, and it's clear. That's the first level of knowledge. And in an architecture of AI, we believe that all that knowledge should sit in the neural network because this is where you get things instantaneously from input to output. However, if she's been asked about 2 medications that she's familiar with, but she didn't administer them yet together, she might need to think about it. She might need to reason. She might need to think about what's the mechanism of influencing the body and other things. And then after thinking about it and putting it in a new way because she's never thought about it in the past, she can come with an answer. That's a second level of knowledge. And we believe that this needs to sit within the AI system as a symbolic, explicit, intelligible knowledge structure. So this is a knowledge structure where if you're that dentist or if you're a person at home, where all the information about who you are, who you're working with, that you want to be collected, is collected and structured there with the right ontologies, with the right relationship between things. So that's the second level. It's kind of a potential for future questions and future asked without overburdening with memorization for the system one habitual system. So that's the second level. Still within AI, it's a deep knowledge-based structure, intelligible, explicit. And then the third level of knowledge, which is an AI has to have access to retrieve information from the world in real time. And there are some systems today that are trying to encompass everything with one huge neural network. But the world changes so quickly. And also the amount of information that needs to be taken into consideration is so large, especially when you're going multimodal, that a much more likely is this access to whatever world information is out there, zettabytes of information. So for that physician, you ask her about two medications and she needs to go and Google it or go to the medical library because one of them is a new medication that she has not worked with. So we believe that this construct of three levels of knowledge, 3K, with an internal neural network, with an internal knowledge base, and with the ability to access all relevant external information when needed, is the blueprint for future cognitive systems.
Yeah, that's really fascinating. Gadi, I wanted to also ask you, there are many people who have the same job across many companies. You've had many jobs across one company, at least for the past most of 4 decades. And I wonder if you could reflect on what has kept you at Intel for so long and made this such an interesting opportunity to explore a variety of different spaces across the company.
Well, I guess a lot of people's journey is what they make of it. And I always wanted to drive the space that's known, to work on this boundary between things that are well understood and things that have not been figured out yet. Not just on improving things that are already being done, but on driving. So when I was driving I was part of the leadership team of Pentium, of the original Pentium, and taking Xeon to market when it was perceived that some architectures can never play in the data center or cloud space. That was a challenge of how do you do that, of taking x86 or Intel architecture. They were doing the smallest architecture with Atom and other spaces. So within Intel is such a rich universe and a great technology company. I was able to find my next step of this journey into the unknown, so that it really allowed for both a personal growth, continuous growth, but also being able to use the strength of the company to translate ideas into impact on the industry and on the broader world. So that was a very good and gratifying combination over the years.
Oh, wonderful. Well, Gadi Singer, thank you so much for joining me today and sharing a bit about the remarkable journey that you've had, but also the remarkable work that you and your team are doing that will create many of the innovations that perhaps we'll see in the not too distant future. It's been a wonderful conversation.
Thank you. Thank you, Peter. Thank you for the opportunity.